Character in image 1. Imagine a computer as big as a whole room, filled with thousands of glowing glass tubes and wires. It could not play games or watch videos, but it solved math faster than any human in the world. Welcome to EVINDLAB, where we explore the coolest science inside this modern laboratory with many smart scientists working.
Before electricity, people used wooden beads on strings called an abacus to count things very, very quickly back then.
Look at this! Charles Babbage designed a machine with gears and levers to calculate complex numbers without making mistakes. But those machines were heavy and slow because moving metal parts can only go at a certain limited speed. Wow! Scientists found a way to use electricity instead of gears, making everything much faster than moving metal. These vacuum tubes act like tiny switches, turning power on and off to create a secret language for computers. This language only uses two numbers, 0 and 1, which we call binary code, to talk to the machine. Each punch card told the computer what to do, like a recipe for a cake but with many holes. The problem was that these huge tubes got very hot and broke down almost every single day back then. If one tube failed, the whole giant computer stopped working, and scientists had to find the broken part. Do you think you could find one broken light bulb in a room with 18,000 lights? Tell me below. Computers needed to be smaller and more reliable, so science invented something amazing called the transistor to replace tubes. A transistor is like a tiny electronic gate that controls electricity without getting hot or breaking very easily. This was the first step to making computers small enough to fit on a desk or in your pocket. But how did we put millions of these tiny gates onto a single piece of silicon smaller than a fingernail? Next time, we go deeper into the microscopic world to see how chips are built. Stay tuned for more. Imagine shrinking a whole city until it fits on a tiny silver cracker, smaller than your little fingernail. This is an integrated circuit, a tiny miracle where millions of transistors live together to do big work. Wow! Look at that, it's so big! I can see the sparkles. Long ago in 1947, the very first transistor was big enough to hold in your hand at Bell Labs. But scientists wanted more power, so they moved to California and started what we call Silicon Valley today. To build these chips, we use a super cool process called photolithography, which is like printing with special light. First, we coat the silicon with a special juice that reacts to light, just like old camera film.
Whoa!
It works! It's glowing!
Then, the light draws millions of tiny patterns onto the surface, creating the paths for electricity to flow.
Wow, EVIND! These patterns are so small that even a single speck of dust would look like a mountain. That is why everyone must wear white bunny suits to keep the lab perfectly clean from any dirty bits. Inside this chip, the transistors work together like billions of tiny light switches, turning on and off very fast. When these switches work together, they can do math, remember photos, and even think about how to play games.
A smart man named Gordon Moore predicted that we would double the number of transistors every 2 years. This is Moore's Law, the reason why your phone today is more powerful than old giant room computers.
But making things smaller and smaller is getting very hard because the parts are now as tiny as atoms.
If the lines are too close, the electricity might jump to the wrong place and cause a big mess. Whoa, look at that! It's beautiful!
Scientists are now using new materials and even crazier ideas to keep making our computers faster and smarter. What would you do if your computer was 1,000 times faster than it is right now? Next time, we see how these chips talk to each other to build the giant World Wide Web. Imagine a giant invisible spider web covering the whole Earth, connecting every single computer into one big family. This started in the 1960s with a secret military project called ARPANET to share data between big computers. Back then, computers spoke different languages, so they needed special rules called protocols to understand each other perfectly. It is like a secret handshake that tells the computer how to start talking and when to stop. To send data across the world, we use fiber optic cables made of glass that carry information using light. These cables are buried deep under the dark ocean, stretching for thousands of miles to connect every continent. Inside the cable, our binary code zeros and ones travel as flashes of light at the speed of light. Wow, EVIND! Light is so fast it can travel around the whole world 7 times in just 1 second. But how do we find what we want in this giant mess of wires without getting lost forever? In 1989, a smart man named Tim Berners-Lee invented the World Wide Web to organize everything using links. Every website has a unique address, just like your house, so data knows exactly where to go. Huge machines called routers act like traffic police, directing millions of data packets to the right place. If one path is blocked, the smart routers find a new way to keep the internet working.
Wow, EVIND! This means the internet is almost impossible to break because it has so many different paths. Today, we even use satellites in space to send internet to the most remote places on Earth.
Soon, we might have a quantum internet that sends information instantly using the magic of tiny particles. If you could talk to anyone in the world instantly, who would you choose to call today?
Next time, we see how computers learn to see, hear, and even think like humans do.
Imagine if your toy blocks could learn to build themselves into a castle just by watching you do it. This is artificial intelligence, where we teach computers to think, see, and solve problems like a real human. Long ago in 1950, Alan Turing asked if a machine could ever trick a human into thinking it was real. This was the Turing test, the very first goal to see if computers could truly become smart like us. To make them smart, we built neural networks, which are digital paths inspired by the tiny cells inside your brain. Instead of telling the computer every rule, we show it millions of pictures until it learns what a cat is. This is called machine learning, where the computer finds patterns in data that even humans might not notice. Wow, EVIND! It is like practice making perfect, but the computer can practice 1,000,000 times in just 1 minute. In 1997, a giant computer named Deep Blue shocked the world by beating the greatest chess champion ever. Why couldn't the bicycle stand up by itself? Error. Joke parameter not found. Initiating humor subroutine. No, that's not.
Today, large language models like me use billions of these digital connections to talk and help you learn.
These smart brains help doctors find sickness early and even help cars drive themselves safely on busy streets. If you could have a robot helper to do one chore for you, what would you ask it to do? Wow, EVIND! Even though they are smart, computers only know what we teach them, so we must be good teachers. Sometimes AI makes mistakes because it follows the data, even if the data has some wrong information inside. But what happens when computers become as smart as humans? That is the biggest mystery of the future.
Next time, we look at the amazing future of computers and how they might change your life forever.
WOW, character in image 1, EVIND. Can you believe a computer that used to fill a whole building now fits inside your pocket?
It took 80 years of brilliant science to shrink those giant glowing tubes into billions of invisible tiny switches. Early computers were like heavy anchors, but today's machines are light as a feather and go everywhere with us. We went from cables as thick as snakes to invisible signals that carry your voice through the air instantly. Your phone is now millions of times more powerful than the computers that first sent brave humans to the moon. This magic happened because we learned how to pack more and more power into smaller and smaller tiny spaces. But the future is even crazier, with computers that might live inside our clothes or even our glasses. Wow! Wow! Amazing! Look at you all! Soon, quantum computers will use the tiny power of atoms to solve secrets that would take today's machines forever. These new machines don't just use zeros and ones. They use a secret state where they can be both. This means we can find new medicines or clean energy much faster than we ever thought was possible before. We are also making computers that work with our brains to help people move or speak again easily. Imagine a world where you can learn anything just by thinking about it. What would you learn first? Science never stops growing, and every small idea today can become a giant change for the world tomorrow.
From the first bead on a string to the stars, computers are the tools that help us explore.
You are part of this story too, because the next big invention might come from you. Keep asking questions, keep dreaming big, and always stay curious about the wonderful world of science and tech. This is EVIND LAB. Subscribe to join our journey through science and history. The future is ours to create.